Sorry.
Okay. What do we know about similar triangles from grade 9? Nothing. Okay. Do you guys remember scale factors? Okay, I'm using graph paper because I might actually be able to do one that makes sense. Oh, okay. So here's okay, all right. So we know a little bit about similar figures. The thing we know about similar figures, gentlemen, is that all the sides are either reduced or increased by the same amount. Okay? So if my blue triangle is my parent function, if this one is my parent and this one is my transformed, what happened to the lengths of my sides? Divided by 2. It compressed, right? Like it got smaller. So that's what you know about these. So each side was reduced by a factor of a half. Right? We'd have a horizontal compression of a half, we've had a vertical compression of a half. So, but it has to be the same. If this goes down by a half, then this has to go down by a half, and this has to go down by a half, right? So all the sides reduce or increase, depending on what your scale factor is, by the same scale factor. There's also something else very exciting about similar, well, these are triangles, but similar figures. No? Okay. I'll ruin the surprise. All the angles are exactly the same. So if this is 90, this one will be 90. And if this one is 30, the similar one will also be 30. Does that make sense to everybody? So that's why we can use similar figures in what we're about to do. So that's the stuff you need to know from grade 9. Ta-da! It's like you learned it. It's like you were there. Okay, similar triangles on the unit circle. So point P lies on the intersection of the unit circle and a line joining the origin to the point 4, 3. Find the coordinates of point P. Got it? Awesome. Okay, proud of you. What quadrant am I in? Quadrant 1, right? We know that because both positive. Okay, so we know we're in quadrant 1. So I've got this point out here. That's at 4, 3. Now here's my unit circle. But I've got this point beyond the unit circle. Oh, got to close my brackets. Yeah, we need to make sure we have brackets when I ask for coordinates. You really do need to put brackets. Makes me sad. Okay, then it's asking for, so we have a line that connects the origin to here. It's asking, this question is asking for, this is point. I want the coordinates of that point, the one that sits on the unit circle. And we can do this because we're smart people. We are smart people. Okay, so what we're going to do is we're going to make a pink triangle. Everybody ready for that? It's very exciting. There's the pink triangle. There would be my 90 degrees. Hey, it looks pretty good to me. What is the base length? 4. Because my x is 4, right? So the base length here is 4. What's the height of my triangle? 3. What's the hypotenuse of my triangle? A squared plus b squared equals c squared. Who got it? 5, Pythagorean triple. Do you guys remember those Pythagorean triples? Anybody know the next one? What's the hair in my mouth? Pardon? Do you want me to tell you? It's 5, 12, 13. That's another Pythagorean triple. It might not be the next one per se. What else do I know? I know all kinds of things. Oh, that's not where I am. What else do I know about this? Okay, so now we need to figure out our little triangle. Our little tiny triangle. So cute. So cute and little. It's so awesome. Okay, here we go. Oh, I'll make it blue, just because I'm on a roll here with blue. Okay, what do we know about the side lengths of this?
It's 1.5.
How do you know it's 1.5?
Because I have 3.
But nowhere does it say that there's a scale factor of a half. Right? Like it doesn't say anything reduces by it. You only know one piece of information. What do you know? All you know is the hypotenuse here. What's the hypotenuse? 1. Because it's the unit circle, right? So we know the radius of 1. So proud of you guys. What do we know? Maybe this is the way to do it. Maybe I won't do similar figures. What do we know the coordinate pair on here is? On the unit circle?
The root 2 over 2.
Okay. Okay, I think you're at 45 degrees, but yes, that's what I'm looking for, but I'm looking for more general. I was sorry. It was kind of random. I apologize. It wasn't very directed. That's what I'm looking for. So we know that. I'm going to do it 2 ways. I'm going to do it similar triangle way. And being able to solve ratios is a really good skill to have in your back pocket. I'm going to show you 2 ways to do it. I'm going to show you using similar triangles, using ratios, and then I'm going to show you sine cosine way. You can pick which way makes the most sense to you. You're all going to pick sine and cosine. But that's okay. I love you all. Okay, we know that in our pink triangle, our hypotenuse is 5, right? Okay. What in our blue triangle matches 5? What's the similar side? 1. Okay. What side do you want to solve for first? Do you want to solve for the base of the blue, or do you want to solve for the height of the blue? Height of the blue, okay. So we know that the height is 3. You guys would agree? And on the blue triangle, we don't know what it is. Should I call it H or should I call it Y? Okay, all right, I like the flexibility. Okay, when I have a fraction, when I have 2 fractions and they're separated by an equal sign, what can I do? I can cross multiply. So I'm going to have 5h equals 3. So h is going to be equal to 3/5. Yep, I can. I'm just going to pop it off the page just for a second, though. So 5 over 3 equals 1 over h. This is my big triangle. This one is my small. You just want me to do the math. You're not concerned about this part. Okay, so okay. What would be the best way to do this? I want to get h off the bottom. So what's the opposite to dividing by h? Multiply by h. So I'm going to multiply this side by h. I'm going to multiply that side by h. So what happens to my h's over here? Gonzo. So I'm left with 1 on this side, and I'm left with 5h over 3 on this side. Got it? And then multiply both sides by 3, and that's how we get that. Okay. So what did we just find of our coordinate? We found the height. So in the coordinate p theta, we know which value is 3 over 5. Why? Because it said that in the equation, or in the question. Point P. All right, so now we got to find the x value. And so, again, we're going to put those together. You have to have a matching set in order to do this. And what I mean by a matching set is like a hypotenuse and a hypotenuse. Yeah?
Could we just do hypotenuse here?
Oh yeah, you totally could at this point. Yeah, yeah, at this point you could.
Okay, yeah.
Yeah. I'm going back to cross multiplying because it makes me feel better. So now this is going to be 4. So you notice that the similar sides are on the same, like they're on the top of my fractions. Okay, they're on the top of the fractions. They have to be on the same level. Like you can't have a 5 and you're 1, like 5 in the numerator and 1 in the denominator. They have to be along the same. You can put them both in the denominator. It won't affect anything. So this is over, I'm going to call this B for base. Now I'm going to cross multiply again. I have 5b equals 4. So b is equal to 4/5. And that would be my coordinate of that point. I will tell you that this is a super handy skill to have, setting things up as ratios. Yeah, they really are. They really are. Okay, so this is option 1. This is option number 1. Do you guys want me to do option number 2 for this question because you know what the answers are? Or do you just want me to jump into option number 2 down here? Okay. Don't waste your time. I like it. All right, so example number 2. What quadrant are we in? We're in quadrant 2. Okay, so we know that this is -3. We know that's +6. Anybody know the hypotenuse? This is not a Pythagorean triple. So we actually got to math it out. But what's one thing we know about the hypotenuse here? It's going to be positive. The hypotenuse will always be positive here. Because when we do Pythagorean theorem, it's going to give us the positive principal root because we're squaring things, so that -3 is going to go away. Okay, so 6 squared plus -3 squared equals c squared. 36 plus 9 equals c squared. 45 equals c squared. 45 equals c squared, so we have root 45 equals c. Can we simplify that radical? Yes, we can. So 3 root 5 is the answer, but we probably have to slow our roll. Okay, I'm just going to go to the scrap piece of paper for a second. So if I have root 45, I'm looking for the factors of 45 that have a perfect square in them. And I'm looking for the largest perfect square. And it's why I'm looking for the largest perfect square, because it's a square root. If it was a cube root, I'd be looking for the largest perfect cube. So 45, it's going to be, it's going to be your 5 and your 9. Because which one of those, it's 9 that's going to be the perfect square. So we're going to go root 9 times root 5. Can I take the square root of 9? So I'm not changing the value of anything, I'm just changing how it looks. Don't like it, I love it. It's going to be great. Okay. All right, so now I'm going to teach you the other way. So we remember that the coordinate pairs are cos theta, sine theta when on the unit circle. So what we're looking for here is this point. So we're looking for the coordinates at that point, and we all agree that that point is on the unit circle, right? Okay, yeah. Mm-hmm. What? Sorry. That's the hypotenuse, sorry, yeah. 3 root 5 is the hypotenuse. That is a terrible 3 root 5. I don't even know what that says. No judging here. Okay, so we're not even going to worry about the little triangle. We're actually going to do sine and cosine of the big triangle. Everybody good? All right, so what is cosine? So remember that my angle will be down here. So cosine is going to be -3 over the hypotenuse measurement.
Why is, I like the other way with the or something.
What? So what's cosine? Cos theta is equal to adjacent over hypotenuse. So when I'm looking at,
Oh, never mind, sorry.
okay. So that's the triangle I'm looking at. Okay? Okay, can we reduce that? So you see the benefit of simplifying that radical? We can now reduce it. So we're going to have cos theta is equal to -1 over root 5. And I'm not even going to ask you to rationalize that denominator. Although you totally could if you wanted to. Wow. Wow. I was kind of excited for that, but way to ruin my fun. So now we're going to do sine. So sine is going to be 6 over 3 root 5. Can I simplify that one? Yes, I can. So what's the coordinate at that spot?
I like the other way way better.
Really? Really? The example, the first example.
The other way
It's
better.
way easier, it's like simpler math.
Do people usually like the triangles way better?
Yes. Really? Okay, you guys blew my mind. No one loves the ratios. I will tell you, ratios is a super good skill to have, but no one ever loves that. Do you think it's because we had to simplify the radical here? But
This method on the other.
I like.
do the first method on. Okay, so if it's the radical messing with you, guys, you're gonna have to do that no matter where you are.
It's easier. Cross multiplying is easier. Less.
Okay, can.
We do enough of these ratios in physics. I don't like.
Okay. Tirth, do you want me to do the first example with the cosine sine?
I mean, it like Excel or data.
Okay. We did finish this one.
Like the second one with the other.
Oh, you want me to do this one with the other method?
No, like, were we in the middle of the question? Like,
No, we're done.
that's our answer.
Find the coordinates. Coordinates? Found them. I love it. Madison's like, finish the question before you move on. I thought I did. I'm sorry. Sorry. But I put them in brackets.
Oh, you didn't put the P theta.
Okay, sorry.
Yeah, put P theta.
You don't have to, no. Okay. All right. So two methods, both get you to the exact same answer. It's whatever you feel most comfortable with. And yes, you're going to have to simplify radicals. Okay? Whether you like it or not, depending on the question. All right. I feel like you guys did this in grade 11 and you struggled with it. I don't know if you struggled with it, but it seems like it was something that we struggled with in grade 11. But when you really stop and think about it, I think if you take your time, it is quite simple. Okay, but restrictions are going to be your life. Okay? Restrictions are going to become your life. They stink. I love it. How to find a missing circular function. And circular, I just mean sine, cos, or tan. Like if that doesn't make sense to you. All I mean are those trig functions for when one function is given. So if I give you sine, how do you find cos and tan? Okay, pretty easy. It's going to involve Pythagorean theorem. Okay, so first of all, you got to identify the quadrant, and that is from the restriction. So I know I threw some restrictions in the last assignment? 2 assignments ago? Last assignment. And it was painful, and I don't know if I definitely didn't do a good enough job explaining what they meant. And then we're going to use a ratio to set up the triangle. And then we're going to solve for the other ratios. Easy peasy, right? Okay, so first of all, this is my restriction. and it tells me what quadrant I'm in. It does not tell me an angle measurement. It just tells me where I am. Where am I looking on the unit circle? So where am I looking on the unit circle? Quadrant 4. Yeah, look at the numbers. So this would be 3 pi over 2, pi over 2, pi, and 2 pi. So if I read this, what does that say? Start with the variable. So the variable says theta has to be greater than or equal to 3 pi over 2. So we know that we're not going backwards. Like if I go to 3 pi over 2, I have to continue to go counterclockwise. If I read it this way, it says theta has to be less than 2 pi or equal to 2 pi. So this is telling me I'm in quadrant 4. Super important to be able to interpret those. And they're not in nice, like, I think we always go to the brackets, like round brackets, square brackets, and we never deal with the less than or equal to signs. But you need to know how to read them. Okay, we're in quadrant 4. We're going to draw this triangle. Where does my theta go? Against the x-axis or against the y-axis? X. Always x. Okay, so we're going to go here. What did I tell you about hypotenuses? What did I just tell you about hypotenuses? Always positive. So where does the negative live? It lives upstairs with the 3, right? So this is like saying, and you guys know sine is opposite over hypotenuse. You guys agree with me, right? So looking at this triangle, knowing here's my 90 degrees, knowing here's my theta, 5 is my hypotenuse, the height, the 4 is the other one because it's a Pythagorean triple. And does this not make sense? Because we know our y values in quadrant 4.
If you didn't know it was 4, though,
You just use the Pythagorean theorem to find that. So 5 squared equals negative 3 squared plus, I don't know, we'll go b squared. So I have 25 equals 9 plus b squared. 16 equals b squared. 4 equals b. Remember that your hypotenuse always has to be c squared in this, so that's 4. And it's a positive 4. So knowing where you are in the quadrants, you're going to either put a positive 4 on or a negative 4 on. But because we are on quadrant 4, I know my x is positive. Okay, so it says find cos and tan. So now that you have your triangle measured, now this is easy. Cos of the angle is equal to, which is 4 over 5. And we anticipate, because we know our cast rule, that cosine should be positive the ratio for cosine should be positive in quadrant 4. And tan is going to be opposite over adjacent. And again, we know in quadrant 4, tan should be negative. So there's ways kind of like to check as you go, if you feel confident enough to do that. Literally, that's it. You guys did this in grade 11, and it was the worst thing ever.
Can you do it the other way?
No, this one has to be done this way. This one has to be done this way. This isn't finding coordinates. This one is finding the other trig ratios.
People pick that way, because then they don't get mixed up.
Could be, yeah, for sure. That's a really good point. I never even thought of that. Okay, one more new skill. I need a pop quiz. Pop quiz. It's not a pop quiz for you guys. I meant I needed the sheet. And I need a handy dandy protractor.
Oh,
Whoa, things are getting serious now when you get out a unit circle and a protractor.
are we gonna need to do that?
No, you're not. But I want to prove to you I'm right. Okay, so there's a pattern on this unit circle. There's a pattern on this unit circle that you might not have seen because we haven't really looked at it. I'm going to pick pi over 6. I'm going to pick pi over 6. Or 30 degrees, whatever floats your boat. So here's a pattern that we don't normally see, but it is there. Every 90 degrees you travel, your coordinate pair switches places. It inverses. Your x's become your y's and your y's become your x's. So for every 90 degrees you travel, you're going to see a flip. So if I go 90 degrees from 30 degrees, if I travel an additional 90, where am I? Hopefully I'm at 120. You guys agree with that, right? And if I use my handy dandy protractor, just because I pulled it out, is that 90 degrees? Almost, kind of, sort of, if I do it right. So we traveled from here to here is 90 degrees. This coordinate pair is root 3 over 2. It starts with root 3 over 2 and then goes to 1/2. Travel 90 degrees, what do you notice? It flips. Now, your positive negatives are going to change based on where you are, right? But the actual values of your x and y, every 90 degrees you travel, it's going to switch. Now, if I go another 90, what's going to happen? Switches back, right? And if I go another 90, well, I'm where I started. So if I go another 90 from 120, 120 plus 90 is 210. And I'm right back to where I was. Okay? Okay, if I go another 90, it's the opposite again. Okay, so do you see that pattern now on the unit circle?
That's a way easier way to remember the unit circle.
Oh, really?
That's how I did the math quizzes through those
Oh
patterns.
my god.
And that's what I wanted you guys to do, is spend some time looking at the patterns that are there.
Just memorize the first quadrant and then just go 90s and then just keep switching.
True story. Okay. All right, you ready?
Yeah.
Okay, so here we go. We're going to find the coordinates. Here's the given coordinates. This is where we're starting. I don't know the angle. I know we can figure it out, but the angle doesn't matter. The question is asking me to find the coordinates. So I don't need to find the angle. I need to find the coordinates. All right. Where am I? Where am I starting? I'm starting in quadrant 1, which is important to know because when we move, we've got to figure out whether our coordinates are positive or negative. So we are going to go, which direction are we going? Forwards or backwards? We're going back. So if I'm in quadrant 1, where is this one? Quadrant 4. So if you were in quadrant 1 and I told you to subtract 90 degrees, you're going to be in the negative, so you're going to be in quadrant 4, like you've rotated around. So you kind of have to get like some visualization here. So we've gone 90 degrees. So what's going to happen? Coordinates are going to flip. So my new coordinates are root 3 over 2 and 1/2. And I'm in quadrant 4. So y is going to be, that's it. Yep.
Are we gonna have like a unit circle when we do our test, or do we gotta memorize it?
I'm going to give you a blank unit circle.
Oh, that works, yeah.
Okay? So you can vomit all your information onto a blank unit circle, but it's yours, right? Like it's not pre-made. So all these strategies are going to be helpful to you. Okay, let's do this one. So we're going back to quadrant 1. We're starting in quadrant 1. And this time we're adding pi. So we were in quadrant 1. 90 would take us to quadrant 2, 180 would take us to quadrant 3. Okay, so what are my coordinates?
The same.
The same, because they flipped and then they flipped back. But we're in quadrant 3. So both of them are negative. Nice. Okay. And that's the end of today's lesson. Look at us.